Hi, this will be lab class 9. Again I will request my teaching assistant Arjun to show it to you the demonstration of MQ3 gas sensor using Arduino. You see, we are taking example of Arduino, so that you can easily interface that particular several sensor actuators with the existing Arduino board in your laboratory, in your department, right, because I am sure that lot of colleges they at least have, or they should have Arduino board. What I am saying at least, because at least is compared to the microfab lab. Okay. Otherwise I am sure that you have lot of facilities over there in the lab, but in particular you should have the Arduino board. If you do not have it, just buy it, it is very cheap, or it is a really economical in other terms. If you have Arduino and if you get a sensor, how can you interface it, right? For example, gas sensor. Now how gas sensor will work? Most of the gas sensor are resistive type gas sensor. What does resistive type means? That when there is a gas, there will be change in resistance. Now I do not want to really see the change in resistance, I want to see what is the concentration of the gas that a gas sensor is sensing, is not it? Because finally what is the concentration of methane leaking in a gas line? That is what is what should be of our interest. So that concentration is always given in parts per million, right, or ppm, or parts per billion, ppb, right. So if I want to interface my gas sensor and I want to display it on a screen, right, how can I interface this gas sensor which is change in resistance, and finally how can I connect my display? You can use a Arduino as a processor in between. So we will be talking about this particular interesting laboratory experiment where you can use gas sensor and you can interface with the Arduino board to finally show some display which is of use to us rather than only looking at the change in resistance. Alright. So you feel free to ask me any questions or any one of us through the NPTEL forum. We will be very happy to answer your questions. Till then, you take care. I will see you in the next lab class. Bye.
Hello, welcome to the Sensors and Actuators course. Today we will be discussing about some sensors. Okay, you must have seen the presentation by Dr. Pandya. Okay, so before going into it, I will be showing the a Arduino Duo board. So previously we have used an Arduino Mega board to show the interfacing with Arduino and the working of sensors. Today I will be using Arduino Duo board. You can see it's having a different color from that of Mega. Other than that, you will see that most of the things remain the same. So this is a genuine Arduino, so that means it's an original one. Okay, some other changes can be, you can see that the connections, it has micro USB connectors. So this one, there are two micro USB connectors here. One is a net programming port and this is the native USB port. So the specialty about the Arduino Duo is that it has a Atmel ARM Cortex M3 microcontroller over here, which is way powerful than a Arduino Mega, the controller in the Arduino Mega, and it is a 32-bit controller. Okay, so it also has 512 KB flash memory, so you can do more coding as well as you can store more data into this board. Okay, so this is it. And different applications of Arduino Duo are like it can be used as a mouse, it can be used as a keyboard, etc. Okay, so that's it about it. Other than that, there are 54 digital input output pins, there are 12 analog pins, okay, and there are also PWM pins over here. Similarly, you have communications, UART communication over here also. Okay, so that is about the Arduino Duo board. It can be used similar to that of Arduino Mega only. For programming, you have to just use the programming micro USB port over here. Okay, so I will be using this board to interface some of the sensors and we will be showing you that. Okay. So before using the Arduino Duo, I would also would like to introduce the Arduino Duo in the IDE platform. So Arduino Duo does not come by default in Arduino IDE platform, so you have to add it. I will just show you how to do that because otherwise you might not find the board over here. Right now I have installed the one Arduino Duo also in the IDE, but otherwise when you take the board here, you won't find Arduino Duo here. So you can see these come after a line, that means it was not there before. So what you have to do is under this button, the board manager, you click it, so it will show different type of boards that are available. Okay, you can type DUE here. So it will show here Arduino SAM boards, 32-bit ARM Cortex M3. Okay, this is the package that is containing Arduino DUE. Okay, and you can select the version also. And I have the button for removing that add-on here. But in case you haven't installed it, you will have an install button. You just have to press it. So a downloader will download it and install it. So that's how you install a new board. Okay, so you can use this option to add the DUE. So once that's done, under the tools, the DUE will come over here, and you have to select the programming port, because I told you it has both programming port as well as native USB port. Okay, so that is it. Now we will discuss about a sensor now. So we will be discussing about a gas sensor today. So this is a practical example or a commercial example of a gas sensor. So Professor Pandya must have told you that there are different type of gas sensors and different working principles. Okay, you must have also heard of metal oxide based gas sensors. So this one over here on the right side corner, the MQ3, is a commercial gas sensor. Okay, so this is widely used for the detection of alcohol. Okay, and you can see here the other sensors in this series. MQ3 is for alcohol, ethanol, smoke, while for detecting methane and CNG we use MQ4. MQ5 for that we can, with MQ5 we can detect natural gas, LPG, etc. So why it can detect multiple ones are like a metal oxide. This is a metal oxide gas sensor, and one metal oxide may not be too specific for a single gas, but it can detect multiple gases. That's why, or they are not sensitive to just one but multiple gases. That's why they have like different ones under this category. Okay, so I will be showing a demo with the MQ3 gas sensor. So MQ3 gas sensor works based on redox reaction happening, and it there will be a change in impedance due to this redox reaction. You can see on this right side there is a small schematic of the system over here, how it works. Okay. This is not IR sensor, this is a gas sensor, sorry. Okay, so this one over here, you can see AA, BB. So this is the internal construction of this gas sensor. So if you remove this orange part over here in the MQ3, you will be seeing something like this. So AA and BB are the electrodes. The electrodes can be gold or platinum. Okay, so there are, this HH is actually a heater coil. So what does a heater coil does is, when current is passed through it, it will create heat. Okay, this heater coil is covered by a tubular ceramic aluminum oxide covering. Okay, and above this aluminum oxide tube, we have tin oxide or stannous oxide coated. So what happens is, here the stannous oxide is the metal oxide that is causing the detecting phenomena. So what happens is, when we expose the stannous oxide layer with alcohol, what happens is a redox reaction will happen, and a change in impedance also happens. So since a heater is over here, you can also feel that when you touch here while the sensor is in operation, there will be a small heating. I will demonstrate that also. So this is the constructional details and working concept of the MQ3 gas sensor. So most of the gas sensors are like this only, but only thing that the metal oxide that will be coated will be different. In some cases it won't be metal oxide, it will be something else. Okay, so that's it. And the heating element is by made up of nichrome. Okay, and yes, the sensing range of this sensor will be 0 to 0.05 milligram per liter of air to 10 milligram per liter. Okay, of alcohol in air. Cool. So this is widely used as breath analyzer, industrial alcohol gas alarm and all. Okay, so I will be demonstrating the working of this gas sensor now. So what you see here is the MQ3 gas sensor. I am having a module over here, and you can see that this orange center that you saw in the video of this slide also. And if you look carefully, you can see the heater coil and the assembly inside. Okay, and this is the back end of it. You can see a trimmer over here. So this is this sensor here has both digital as well as analog output. Okay, so this is for, as you have seen, this is an this is used for detecting alcohol, and its output can be analog also. So when the concentration of alcohol increases, it will start its resistance will decrease, and also you will be getting a increase in analog value output, that is in the range of 0 to 1023. Okay, and you can see 4 pins are here. One is analog output, digital output, ground, and VCC. So as I said, this is basically a analog output only, but it has a comparator on board. So what it does is, based on the potentiometer value that we, or the trimmer value that we are setting over here, when we adjust it, it will compare that with the analog value generated, and if it's greater or less than that, accordingly a digital output will also be given. Okay, so if the analog output is greater than the trimmer set value, it will give a digital high, and similarly if the analog value output is less than the trimmer set value, then the digital output will be low. So we can get both analog as well as digital output. I will be showing the demo with the analog thing, so that by code also you can set the threshold, or if you want to directly get the digital output from this thing, you can just adjust the potentiometer and use it. Okay, it is basically based on your application only. So I am connecting it to the jumper wires I have. Okay. So I have connected my MQ3 gas sensor now. Okay, now you can see here I have connected this to the Arduino DUE board, and the analog output of the gas sensor is connected to the analog pin A0 of the Arduino DUE. The ground and 5 volt are also connected to the board, and for better understanding, I have connected a buzzer also in the breadboard, and I have connected the input pin of the buzzer to the digital pin 22 of the Arduino DUE, so that if it goes above the threshold, if the alcohol is detected and the threshold is crossed by the amount of alcohol, then the buzzer will sound. That's how we are going to program it. Okay, now we will see the programming part. As I said, the MQ3 has a heater inside. Okay, a nichrome heater wire inside. So I'm just showing the temperature of this one right now using a laser temperature meter. Okay, infrared thermometer we call it. You can see that the reading in the infrared thermometer is around 31.4, okay, 31.3 degrees Celsius, and we will check the temperature again after we start using this. So this temperature will be going up. Okay. As I said already, while we are connecting the circuit, this is the Arduino code for this. So I have connected the analog pin of the gas sensor to analog pin A0 of the Arduino DUE, the buzzer to the digital pin 22. I have kept a integer value, alcohol value, as 0, so that initially we need not have any junk value stored into this one. So we will be storing the amount of the analog value from the sensor in this variable, and I have also set the alcohol value limit as 500. So this is a arbitrary value I have put right now. So since the analog value from the MQ3 will be in the range of 0 to 1023, this value limit is in between, like middle of the range, so I have just kept it. We can change this one. So as we increase the value limit, the threshold is actually moving high, so you have to show significant amount of alcohol so that it will be detected. If we reduce this value even for small amount of alcohol, the buzzer will be going, making the sound. This sensor can be used for different applications, and we have seen a lot of our friends making projects based on this. Alcohol, they bike that has a helmet that can detect alcohol, and if the driver has used alcohol, then the bike won't switch on or get on or something like that. So you have heard of such projects. So these use the MQ3 gas sensor only. Now to just see the analog value, I have used the serial communication also here, and I have defined the buzzer pin as output. Now I already told you that analog pin need not be defined as input in the previous sessions, so I am not I haven't put that here. Okay, so inside the void loop, I have set the alcohol value is equal to analog read of sensor pin. That means the sensor pin connected, that is A0, the whatever value that we get from A0, it will be stored in alcohol value. It will be printed in the serial monitor also, and you must be experienced with embedded C or most of the C++ or C. You will be familiar with the syntax. It's simple only, that is even if you are not used to it. As you can see, if alcohol value, if is the same English if we use, so it's like if alcohol value is greater than the value limit that we have set here, then digital write buzzer pin comma high. That means if the alcohol value that's been detected is more than the limit that we have set, then the buzzer pin will go high. That means the buzzer will be making the sound. And otherwise else, then switch off the buzzer or the buzzer won't make sound. This is the code that we have done. Okay, now I am going to upload this code. Before that I am showing you, I have connected the DU board, and I have selected the DU board and selected the COM board correctly. Okay, so I am connecting the Arduino DU board into my PC, and I am uploading the code. You can see that the LED on the sensor has turned on. That means the sensor is on now. Okay, so the heater must be on now. Okay, we are done with the uploading. So the code is being uploaded to the Arduino DU. What I have here is ethanol, 95% ethanol. Okay, this is alcohol only, which can be detected by the gas sensor. I am just pouring a little bit into the cotton over here. Okay, so this, since alcohol is volatile, if we show it to the sensor, according to the code, the buzzer will be making the sound. See, as you can see, when I showed it, it's making the sound. And you can see that it took some time to go back to its normal state or the off state, even after I removed the cotton swab. It's because of the fact that some reaction happened inside the sensor, and it takes some time to reverse the change. Okay, see, my hand is not detecting, but if I show the swab again, because of the alcohol in it, it will again make the sound. Okay, we can just see once in the code again. Okay, I am just taking the serial monitor. So you are seeing a lot of values here. So this is the output, analog output from the sensor now. I have explained this before. Now, while you are seeing these values, I am going to show the cotton swab to the sensor, and you can hear the sound and how the value changes. See, you can see that the value has increased above 500, which is the set threshold. Now I am moving the cotton swab close to the sensor, and it's showing this value. Now I am removing it. I have removed it, but still the value is getting down only slowly. It's because the reaction is slowly getting reversed. See, it has gone below the limit. So this is how analog input is taken from the MQ3 sensor, and it can be used to detect alcohol. See, at the end, like, the value is decreasing very slowly only. Okay. So as I told earlier that the heater inside is there, so the sensor will be heating up a little, and you can see the reading from the infrared thermometer. It's around 36 degrees Celsius, right? That means that heater is creating the increase. Earlier it was around 31 degrees Celsius. So that's what the importance of heater inside. Okay, that's it about the MQ3 gas sensor.